Graphing and solving inequalities. Today we'll graph inequalities, solve one-step inequalities, and then two-step inequalities. To graph inequalities, let's recall our inequality symbols. Less than, greater than, less than or equal to, greater than or equal to. The less than and greater than sign, when we graph them on a number line, we use an open circle. The less than and equal to symbol and the greater than and equal to symbol, when we graph those on a number line, we fill in the dot, or we use a closed circle. The less than and equal to sign, the arrow is pointing to the left, and that's how we draw our graph. And when you have a greater than or equal to sign, the arrows are pointing to the right. Now this works when the variable is on the left side of the inequality. And we always want to solve with the variable, like here, x, is on the left side. If the x was on the right side, we would rewrite it and flip the sign. So go ahead and graph these four inequalities. X is less than 0, open circle, to the left. X is greater than 0, open circle, to the right. X is less than or equal to 0, closed circle, to the left. X is greater than or equal to 0, closed circle, to the right. So now we're going to practice graphing. In example 1, we're going to graph x is greater than or equal to 3. So when we're working with the number lines, we're going to look at the number we're going to graph. In this instance is 3. And we're going to put that in the middle of our number line. And then we're going to count numbers to the right and to the left. So go ahead and graph x is less than or equal to 3. Since it's equal to, so we're going to start at 3 with a solid dot since it's equal to. And since the arrow is pointing to the left, that's the way we draw our graph. So x can be anything that's less than or equal to 3. Example 2, graph x is greater than -2. Again, put -2 in the middle of your number line and have numbers to the right and left of that number. X is greater than -2. We go to -2, open circle, to the right. Example 3, graph x is greater than or equal to 6. We're at 6, closed circle, to the right. One-step inequalities involving addition and subtraction. So we're going to solve one- and two-step inequalities just as if we're solving an equation. So in our first example, we have x plus 7 is greater than 13. So we want to isolate x, so we'd minus 7 on both sides. And our answer would be x is greater than 6. Example 2, x minus 8 is less than or equal to -19. We want to isolate x, so we add 8 to both sides. So our answer is x is less than or equal to -11. Example 3, x plus 6 is greater than or equal to -21. Minus 6 on both sides, and x is greater than or equal to -27. Example 4, 11 is less than x minus 5. Our answer is x is greater than 16. We always want to write our answer with the variable on the left side. So let's see how we got this, because here we have the less than symbol and we ended up with a greater than symbol. So what I first did was I added 5 to both sides, and that left 16 is less than x. Well, if 16 is less than x, that means x is greater than 16. So I moved the x to the left, and therefore I needed to flip my sign. One-step inequalities involving multiplication and division. Before we get started, let's remember that when we multiply or divide by a negative, you must flip the inequality symbol. So we'll be solving these equations, these inequalities, the same way we solve an equation. Just at the end, we'll go back and see if we multiplied or divided by a negative number, and if we did, we'll flip the sign. 6x is less than or equal to negative 42. Divide by 6, x is less than or equal to negative 7. Example 6. Negative 7x is greater than 63. We're going to divide each side by negative 7. And since we divided by a negative 7, we're going to also flip the sign. So x is less than negative 9. Let's go ahead and try number 7. The answer is x is greater than negative 24. First thing we did was we multiplied each side by the denominator of 4, which leaves us with x is greater than negative 24. Since we multiplied by a positive number, we leave the same symbol. Go ahead and try number 8. The answer is x is less than or equal to 27. So the first thing we did was we multiplied each side by the denominator of negative 3, which leaves us with 27 is greater than or equal to x. And that's because we multiplied by a negative number, so we needed to flip the sign. But we want our answer with the x on the left side. So if 27 is greater than or equal to x, then x is less than or equal to 27. So I need to flip my sign. Now we're going to solve and graph. Go ahead and solve the equation just like you would on any two-step equation. Determine if you need to flip the sign, and then graph. We subtracted 1, we divided by 4, which left us with x is less than or equal to 3. We didn't flip the sign. We don't need to flip the sign because we didn't rewrite the inequality, and we didn't multiply or divide by a negative number. Negative 9x plus 7 is greater than or equal to 25. Minus 7 on both sides. Divide by a negative 9, so we need to flip our sign. So x is less than or equal to negative 2. Negative 36 is greater than 6x plus 12. So I first subtracted 12 on both sides, which left negative 48 is greater than 6x. I divided by 6, which left me with negative 8 is greater than x. Well, if negative 8 is greater than x, then x is less than negative 8. Example 4. X over 13 minus 10 is less than negative 8. Add 10 to both sides, then multiply by the denominator, and that leaves x is less than 26. Example 5, negative 18 plus x over 4 is greater than or equal to negative 30. Add 18 to both sides, then multiply each term by 4. X is greater than or equal to negative 48. Example 6, 1/3 plus x over 18 is less than 1/2. Our answer is x is less than 3. Let's see how we could do this. So here we have fractions. We have a 3, an 18, and a 2. So I want to find the least common multiple, the smallest number that all of those can be divided evenly into. So I take the biggest number of 3, 18, and 2. Let's write LCM for least common multiple. I take the largest number, which is 18, and then I look at the first number, 3. Does 3 divide evenly into 18? Yes. Does 18 divide evenly into 18? Does 2 divide evenly into 18? Yes, they all 3 divide evenly into this number, so it is the least common multiple. So now I'm going to multiply each term by 18. So 18 over 3 is 6, plus 18x divided by 18 is x, is less than 18 divided by 2, which is 9. Now I'm just going to subtract 6 on both sides, and x is less than 3.